Hello dear children, welcome to maths class. Today we are going to start our new lesson, chapter 4, Identities. Do you know what are identities? Yes, identities are actually equations. Okay, they are equations. We already had a chapter equations. Do you remember? Yes, equations that are true for all numbers are called identities. Okay. So, identities are actually equations. That equations are true for all numbers. Okay, for every numbers the equations are true. Such equations are called identities. So, in this chapter we are going to discuss about identities. In 7th standard, we had a result like this. Do you remember the result? That is x into y plus z. X into y plus z, that is equal to, yes, x into y plus x into z. Okay, that is, this is actually sum of two numbers. Okay, sum of two numbers into another number is actually the sum of the product of that two number with this number. Okay, this is an identity. Okay, this one is an identity. Why this one is an identity? Because it is true for all numbers. If we take any number instead of this x, y and z, so it's true for that all numbers. Okay, so this is our first identity. X into y plus z is equal to xy plus xz. Okay, and it is very useful for us. X into y plus z is equal to xy plus xz. Okay, and here in this chapter, first we are going to find out the product of sums. That is an identity. Product of sums. That is, we are going to find out the product of two sums. Okay. For that, here I am going to use a rectangle. That is, first I am going to give a geometrical explanation for that. Okay. So, see, here I have a rectangle like this. Okay. This one is a rectangle. And for this rectangle, the length is equal to, yes, suppose the length is equal to 7 and the breadth is equal to 5. Okay, this one is a rectangle with the sides 7 and 5. What will be its area? Yes, length into breadth is area of a rectangle. So, area of this rectangle is equal to 7 into 5 is equal to, yes, 35. Okay, area of this rectangle is equal to 35. And if I make a big rectangle by increasing the length by 2 centimeter. Okay, by increasing the length by 2 centimeter and breadth by 1 centimeter. Okay, breadth by 1 centimeter. That is, I am increasing 2 centimeter length and 1 centimeter breadth. Okay, so I got a new rectangle like this with what about its length? Yes, the total length is equal to, this total length is equal to 7 plus 2 is equal to 9 and this breadth is equal to 5 plus 1 is equal to 6. And we know that the area of this big rectangle is equal to, actually it is 9 into 6. Right? This 9 into 6. 9 into 6. And we know that this 9 is actually 7 plus 2. Right? This 9 is actually 7 plus 2. So that is 7 plus 2. And this breadth is equal to 6 plus 1. Okay. Sorry, 5 plus 1. Breadth is equal to 5 plus 1. So here we need actually the product of two sums. Okay. Product of two sums. Then we know the result. What is it? 9 into 6 is equal to, yes, 54. Answer is 54. But we need the geometrical explanation for this product of sums. Okay, for that, here I am going to divide this big rectangle into 4 rectangles. One rectangle is already here. Okay, now I just draw a line like this, and similarly here also. Okay, so the big rectangle is divided into 4 small rectangles, right? We already have the length and breadth of this rectangle, and its sum is equal to, and its area is equal to 35. Then what about this rectangle? What is its area? See, for this rectangle, we can see that the length, breadth is equal to 2 centimeter. Then what about this length? Yes, we know that length is exactly similar to this length, right? So that is equal to 5 centimeter. Then what about its area? 2 into 5 is equal to 10. Okay, and now I am going to find out area of this rectangle. What about its length? Yes, its length is equal to, yes, it is equal to this length. So this is equal to 2 and this one is equal to 1. So its area is equal to 2 into 1, that is equal to 2. And finally here we have another fourth rectangle, and for that rectangle the length is equal to 7 and its breadth is equal to 1 and its area is equal to 7 into 1, that is equal to 7. Okay, so what about area of this big rectangle? That is actually the sum of areas of these 4 small rectangles, right? So 35 plus 10, 45, 45 plus 9, 45 plus 45 plus 2, 45 plus 2, 47, 47 plus 7 is equal to 54. We got the very same answer, 54. But how do we did this? Yes, for that, yes, first we did 7 into 5, right? This is actually the product of two sums. So first we did 7 into 5, right? Then we did 5 into 2 or 2 into 5, right? So it's 2 into 5, that is 7 into 5, then 2 into 5. Okay, then what about this one? This one, that is 7 into 1. Okay, this is 7 into 1 and this one is equal to 2 into 1. So this is actually the product of the sums. Okay, 7 plus 2 into 5 plus 1 is actually, yes, first 7 into 5 plus 2 into 5 plus 7 into 1 plus 2 into 1. Okay, this is actually we did here. That is, if we need the product of two sums, we need to multiply each number in one bracket with each number in the second bracket. Then we will get the product of the sum. Okay, so identity means we need to use yes, variables, that is numbers true for numbers that are representing every numbers. Okay, or alphabets that are representing every numbers are called variables. So here I am going to take 4 variables that are, yes, one is A, B, C and D. Okay, 4 continuous numbers. Or you can take any numbers like that is x comma y and u comma v. Okay, x comma y are 2 variables. Similarly, u and v are another variables. All these are called variables, right? All these are variables. Now I am going to find out the product of their sum, that is x plus y into u plus v. Okay, these two are the product of two sums. Then as we did in the rectangle problem, how do we find the product of this sum? For that, yes, first x into u, that is xu. Then x into v, that is xv, plus y into u, that is yu, plus y into v, that is equal to yv. So this is true for every number, therefore this is called an identity. So this is our second identity. Okay, for easy, here I am going to write the identity using the variable a, b, c, d. That is a plus b into c plus d is equal to, yes, ac plus AD plus BC plus BD. Okay, this is our second identity. Okay, this is our second identity. And what was our first identity? Yes, our first identity using A, B and C. Here I am going to write the first identity, that is A into B plus C is equal to, yes, AB plus AC. Let us multiply each number inside the bracket with the number outside the bracket, then find its sum. Okay, so AB plus AC. And here A plus B into C plus D is equal to AC plus AD plus BC plus BD. Okay, these two are identities. And in this chapter we have some more identities like this. We will explain it. We can use this identity to find the product of some big numbers. Okay, for example, here we have a big number, yes, 14 into 16. 10 plus, we can write this 14 as 10 plus 4 and the 16 as 10 plus 6, right? Then we can easily find its answer, right? Because multiply with the 10 and its multiple, 10 and its powers are very easy, right? So here I am just splitting our number 14 as 10 plus 4 and 16 as 10 plus 6. Okay, now it is very easy to calculate. First, as we did in the identity, A plus B into C plus D is equal to AC plus AD plus BC plus BD. This is our identity. Using this identity, we are going to expand this. Okay, that is 10 into 10 plus 10 into 6 plus 4 into 10 plus 4 into 6. That is 10 into 10 is equal to 100. 10 into 6, 60. 4 into 10, 40. And 4 into 6 is equal to 24. Okay, you can easily find the answer. 100, 60 plus 40, 100, 160. 160 plus 40 is equal to 200. 200 plus 24 is equal to 224. So, we can easily find the answer. Okay. Now, here I have another question like this. That is 6 1 by 2 into 8 1 by 3. Okay, here I am going to find the product of two numbers 6 1 by 2 and 8 1 by 3. And I am going to solve this question using identity. How do we solve this? Yes, I am splitting the 6 1 by 2 as 6 plus 1 by 2 and 8 1 by 3 as 8 plus 1 by 3. Okay, let's just multiply that. That is 6 into 8 plus 6 into 1 by 3 plus 1 by 2 into 8 plus 1 by 2 into 1 by 3. Okay. Then what about 6 into 8? That is equal to 6 8s are 48. Then 6 into 1 by 3. 6 into 1 by 3 is equal to, yes, 2. Then 1 by 2 into 8. That is equal to 4. Okay. 2 is 4 times in 8. Then 1 by 2 into 1 by 3. 2 fractions, numerator into numerator by denominator into denominator, that is equal to 1 by 6. So we have 48 plus 2, 50. 50 plus 4 is equal to 54, and here we have a 1 by 6, that is 54 1 by 6. So it is very easy to find the product of two mixed fraction. So to find the product of two mixed fraction, we can make use of the identity A plus B into C plus D is equal to AC plus AD plus BC plus BD. So by heart that identity, two identities are there. First one is A into B plus C is equal to AB plus AC. Second one is equal to A plus B into C plus D, that is equal to AC plus AD plus BC plus BD. Okay, by heart these two identities and apply wherever it is named. And now we have some calendar problems. Okay, now we are going to do some calendar problems. Do you remember calendar problems that we did in the chapter, chapter equations? Do you remember that? Yes. That is, we know that in a calendar, yes, if we take a square of 4 numbers in a calendar, what is the relation between the numbers in the calendar? Yes, we know that. Suppose suppose this is Tuesday and this is Wednesday. Okay. And this is the first week and this is the second week of 1 month. Suppose this is June month. Okay. And If this Tuesday is 6, then what will be Wednesday? Yes, we know that Wednesday is 7th. Okay, then we know that in a calendar, row represent a week and a column represent days, right? So after 1 week, what will be the number in the Tuesday, or what is the date of the next Tuesday? That is, yes, we know that, right? That is 1 week is the. So 6 plus 7. This number is actually 6 plus 7, that is equal to 13. Then what about this number? That is actually 7 plus 7 is equal to 14, or this number plus 1 is equal to 14. Then if we use algebra, how do we represent the numbers? Or if we take a square of 4 numbers in a calendar, how do we write that numbers using algebra? Yes, if I take the first number as x, what will be the second number in the calendar? That is x plus 1, right? Then what about this number? That is x plus 7, right? And the fourth number is equal to x plus 8. Okay, so this is the relation between the numbers on a calendar. That is, the number difference in the nearby numbers is equal to, or the difference between the numbers in the row is equal to 1, and the difference in the numbers between the column is equal to 7. Relation between the numbers in a calendar. Now we have a question in page number 78, question number 1. That is the first exercise in this chapter. So all of you take page number 78 of your textbook, and the question is, write numbers like this. Okay, numbers are like this. 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10 and 11, 12, 13, 14 and 15, and here 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, 25 numbers are written like this. Then first question, as in the calendar, mark 4 numbers in a square and find the difference of the diagonal products. Is it same for all squares of 4 numbers? Okay, that is, as we did in the calendar problem, here I am going to draw a square of 4 numbers. Okay, this one is a square of 4 numbers. Similarly, this is also a square of 4 numbers. Okay, so here we draw a square of 4 numbers. Okay, in this set of numbers, here I draw a square of 4 numbers, and I need to find the diagonal product. Okay. Find the difference in the diagonal product. Difference in the diagonal product. What do you mean by diagonal product? What do you mean by diagonal? Diagonal means the line connecting opposite vertices. Right? Line connecting opposite vertices are called diagonals. So diagonal product means find the product along a diagonal. That is, if we consider this square, the diagonal product is equal to 1 into 7 is equal to 7, and 6 into 2 is equal to 12. These two are the diagonal product, and we need to find the difference between the diagonal product. What is the difference between the diagonal product? Yes, difference between the diagonal product is equal to, for the first square, the difference between the diagonal product is equal to 12 minus 7, that is equal to 5. Now we need to check this difference is true for every squares in this set of numbers. For that, here I am going to take these 4 numbers. You can take any 4 numbers like this. Okay, now I am going to find out the diagonal product. That is, yes, 13 into 19, and here 14 into 18. That we will discuss in the next class. So this much only for today, children. Thank you.